Hello, welcome to class. My name is Todd. I'm your teacher. We're going to start out by learning one of the most important things, if not the very most important thing that you're going to learn throughout this entire course, and maybe throughout this entire semester, and maybe even throughout your entire life. Because what I'm going to teach you right now is going to make a tremendous difference for you in this class, and it's also going to make a tremendous difference for you as a student through all of your college and university education, and it's also going to make a tremendous difference for you in your life. So we're going to learn that right now, the most important thing. And what we're going to learn about is generative AI. So generative AI, some of you have certainly heard of generative AI and tools like ChatGPT, and you might even be using it. But for others, I know that there's a lot of people out there who have never heard of generative AI or ChatGPT. And for everyone, you're going to see some things in this video, including we're going to get into the first chapter of statistics, but we're just starting out with this first thing about generative AI because it's so important and so helpful. But you're going to see some things in this video that maybe you have never been aware of before. And I'm going to teach you some ways to use generative AI like ChatGPT. I'm going to teach you some ways to use it that maybe you've never seen before or haven't known those things that you could actually do with generative AI and ChatGPT. So that's what we're starting out with. And first, I just want to illustrate the difference between a search engine like Google. So here I am at Google, and generative AI like ChatGPT. So there's different places you could find generative AI. There's like Bing has its own version, Google has its own version, but the best version that I believe, in my experience, is here at chatgpt.com. It's created by OpenAI. So you could go to OpenAI and you can learn about some of the other stuff that they're doing there. And OpenAI is of course, for artificial intelligence, but they're also, creating videos and things like that with AI. And it's pretty amazing. And they call it generative because it generates a response for your questions. And there's some differences between using generative AI like ChatGPT and using a search engine. And we're going to explore those right now. So in statistics, one of the things we're going to learn in chapter 1 is that there are different ways that we could categorize data. And I remember those categorizations as NOIR, right? Noir. So there's film noir, but in statistics, NOIR is an acronym, which for me stands for nominal, ordinal, interval, and ratio. So I could put that in, and here Google gives me a little bit of their Google generative AI, and it gives me a little bit of a description of nominal, ordinal, interval, and ratio. And those are 4 levels of measurement or scales of measurement that indicate how precisely variables or data are recorded in scientific research and statistics. But then what a search engine really does is it gives you a bunch of results of places that talk about the thing that you're interested in. So this is what Google does. This is what Google has done since it started in 1998 for 26 years, was a search engine would take you to resources, right? And it'd be like, here, you want to learn about nominal, ordinal, interval, and ratio scales? You could do that at this link, or at this link, or at this link, or at this link. So it gives you resources which you could then go read through, and after you've read through those resources, you could synthesize some meaning from the different resources that you have read through. The difference between Google, right, which is this, and ChatGPT, generative AI, is that at generative AI, it's going to read through all of the resources everywhere available on the web. It's already read through all those resources. It might update its understanding by reading through a few more current resources. When I ask it a question, it's going to read through all the resources for me. I don't have to read through the resources. I don't have to read through all of this here. ChatGPT read through all of this stuff and more. And when I ask it a question, it's already synthesized. It's already synthesized from all of these resources. It's synthesized an understanding of everything that was written about and said at all of these resources. And then it's going to generate a response specifically for me. It's going to create brand new content, which is why it's called generative. It's generating that content. This content was not generated by Google, the search engine. This content was created by somebody and it's been put at a web address. It was not generated. Here at ChatGPT, the content is going to be generated. And it'll generate it from its synthesis, its understanding of all the information that's already out there. So I could say, please tell me about nominal, ordinal, interval, and ratio in statistics, okay? So, and ordinal, I'm going to take that out, ordinal. So I could put a question there. And so one of the things we're learning about the differences between a search engine and generative AI like ChatGPT. One of the things you'll notice with generative AI here at ChatGPT is you speak to it just like you'd speak to a really smart friend. You could just ask it a question, right? And you can make, you can make your question, in normal language that you'd normally use, right? Talking with a friend. And so here you can see that. Over at Google, what I put in is nominal, ordinal, interval, and ratio. So at search engines, you put in a phrase which is very short, very succinct, best restaurants near me, nominal, ordinal, interval, ratio, right? I just bear it down to the essential concepts. I scale it down to the essential concepts, right? And when I do that as a search engine, it gives me those results here. But here I put in a normal sentence. I could even add in, I think that's what they're called, right? I could even add in ambiguity, like I think that's what it's called, like, and if I wanted to, I could change this from ordinal, nominal, ordinal, interval, ratio, and I could make it integrate. So I'm gonna try to throw it a curveball and put in the wrong word, and I'm gonna hit enter. And what it says in statistics, you're referring to nominal, ordinal, interval, and ratio scales of measurement. So it corrected my mistake. And then it gives me all of this, it gives me like all of this information here, right? And so it's generating this content from its understanding of all of the synthesis. It's synthesized meaning from all of the resources that are out there. And it's generating, generative AI, generating this response for me. This is brand new. The world has never seen this text before. It was created just for me in asking this question. And I could have a conversation. So it's another difference between a search engine and generative AI. At a search engine, you enter a search, you get results, you read through them. If you don't find what you're looking for, you start a whole brand new search, right? It's not like a continuation of a conversation, right? It's a whole brand new search as a search engine. You search for something else, and then you read through all those resources. At ChatGPT, it's a conversation. So you just ask it another question, and that question is related to what you're already talking about here with the machine. And again, you could think of the machine as a really smart friend, right? It's like the smartest person you've ever known. You just talk to it, and you could enter the wrong information, and you could enter ambiguity. I think that's what they're called, right? And it gives you a response. And then you could come in here and you could continue the conversation. And I could say, can you please give me examples of each of those? And I'm going to ask that question here and press enter. But I'm also going to come over here to Google. And at Google, I'm going to ask the same question. And when I enter this question, it's just going to be nonsense, right? Like it's no longer going to be statistics. It's giving me a Google search based upon this crazy sentence up here, right? Can you please give me examples of each of these? There's no context, there's no conversation, there's no continuation of the conversation I was exploring. It's like, it's a brand new search. But over here at ChatGPT, generative AI, right? It gives me some examples of each of those. Nominal scale, eye color, type of car, political party. Ordinal scale, customer satisfaction, education level, class rank. Interval scale, right? It gives me examples of each of those. So I'm gonna I'm gonna just bring this up on screen, and you could pause the video here and you could read through that. Now I'm gonna scroll down and you could pause the video for ordinal scale and you could read through that. And I'm gonna pause, and now you could pause the video here and read through interval scale. And now you could pause the video here and read through ratio scale. And now here you could pause the video and read through those examples for nominal, ordinal, and interval. And then finally you could pause the video and read through the examples for ratio. But that's like the first chapter of statistics in this course. Is we're just learning about data and elements and variables. And how do we talk about data? Because statistics is all about gathering data and making meaning of it. How do we make meaning of different measurements so that we can understand our world? And it's super helpful in business and in all kinds of areas, in science, in medicine. Super helpful to be able to understand data. So this first chapter is really about talking about what words do we use when we're talking about data. So every field, every subject every domain has its own language with which you use to talk about that domain and its own unique vocabulary. So this first chapter is just introducing you to that in statistics. But that's the first thing I want you to know. The first thing I want you to know here is just about the difference between a search engine and ChatGPT, generative AI. And so something else you should know is that there are different versions of ChatGPT. So this is the paid version. It's the best. It'll give you the best responses. This only became publicly available in November of 2022. So really it hit public awareness in January of 2023. And so it's really only been out for a year and a half. It's brand new in the human race, in the human species. And this is the best version. But and it's paid, it costs $20 a month. It's going to give you way better results than the free version. They do have a free version, but that uses an old engine and the results are not always accurate. They're less accurate. Even the free version, just like humans can sometimes get things wrong, ChatGPT can sometimes get things wrong. But this gets things right like 99.5% of the time, 99.8% of the time. I'm just making that statistic up, but it's a really high percentage of getting things right. Whereas the free version, the older version, has more errors. All right, so I really recommend, this is a great educational tool. I really recommend getting the paid version. And you could go and you could do ChatGPT student pricing. And so I'm just entering this, at Google, because this is actually a good task for Google. And so you can look in here to see if they have pricing for students, because sometimes companies offer student pricing. But anyhow, that's an introduction to ChatGPT. Now I want to show you a few things about ChatGPT that not a lot of people know. Down here you have a place where you can upload files from your computer. And if you install the app on your phone, you can upload files from your phone. Why is this useful? Because if it's installed on my phone, I could take a picture of something in the textbook. I could upload it to ChatGPT and I could say, please explain this concept to me, right? Please explain it to me in simpler terms. Please give me a very simple example of this concept. Please give me a problem to practice this concept. I've practiced this problem. Did I get the answer right? This was the answer I got. If I didn't get it right, please tell me where I went wrong. Like you could write out on a piece of paper with a pen your work when you're doing a problem. You could say, this is how I did it. And you could take a picture of it. You could upload it to ChatGPT, and then ChatGPT will look at your work and tell you what you did right and what you did wrong. I'm just making sure that we're actually recording here. So it is phenomenal, and it's like the best tutor you've ever had. And it's great not only for statistics, it's also great for, you need to create a resume, like write a draft resume, put it into ChatGPT, and then say, can you make this better? And you need to write a cover letter for a job application, upload the job posting, upload your resume, and say, please draft a cover letter for this job. I want to apply for this job. And it'll create a cover letter for you. You have to write an essay for school, write a draft of your essay, right? And then upload your essay to ChatGPT and say, can you please help me improve this essay? And then look at your draft, look at what ChatGPT created, and then learn from ChatGPT. It's like the best, smartest tutor you've ever had, the most patient tutor you've ever had, and you'll see how it improved your essay. And you can learn to be a better writer by looking at like your first draft, comparing it to the way ChatGPT improved it, and then creating a third draft, your own draft, where you integrate changes from ChatGPT with your original version to create your third version. And that is great learning. That's just like going to the tutorial center on campus and having somebody who's great at writing on campus work with you on your essay and then integrating those changes into your essay, except instead of going and seeing a human, you're going and seeing a machine, ChatGPT, which actually is better than the vast majority of humans out there at pretty much everything. So it's an incredible tool. It's going to help you in this class. It's going to help you as a college student. It's going to help you in life. And it's one of the most important things you need to learn about today in society so that you could use it well and become more productive and get things done more quickly and also get things done in a better fashion with better output. Even if you have to write an email, you could drop your email draft in here and you can say, please, turn this into a good email that sounds good, and it'll create that email, and then you could edit it to be accurate for who you are. So you could upload all kinds of stuff, pictures, you could upload files, right? You could, like the job application and your resume, whatever anything in a file, spreadsheets, you could upload it here and you could have it analyze it and ask it questions and ask it to do things. So again, just treat it like a genius friend who is willing to help you with anything, and get creative about putting everything into it and seeing and asking it any kinds of questions and asking it to do whatever it can do for you, that whatever you want it to do for you, to see what kind of output it produces. All right, that's the first thing, most important thing that you'll learn. I want to make sure we got that out of the way right at the very beginning. Now we're going to move into looking at chapter 1. But before we do that, I'm just going to come over here to our class. We have this, this welcome page, getting started, getting help, additional useful resources. Then we have the syllabus, then we have modules in here. And in the modules, we have this useful links module, and then we have chapter 1. And in chapter 1, when you see a date and points, those are things you need to do to earn points towards your grade. And then everything else is optional. So this is just a link to the first chapter in the textbook, and then there'll be a link down here to this first lecture. But that's how this course works. All right, so now we're just going to cruise through chapter 1, and we will use ChatGPT to help us learn some of this stuff as we go through this chapter. So you're going to see all of that in action. I'm going to pause this video just for a minute and take a drink of water. All right, I'm back, and I see the little red dot, and I see the seconds going up right there. So that tells me we are recording. And when I come in here, I could see that we're getting the screen. So that is all good. Chapter 1, data and statistics, a lot of definitions, right? But this is what chapter 1 is going to go over. You can pause the video and take a look at that. And then when it asks us what is statistics, it refers to numerical facts, such as averages, medians, percentages, and maximums that help us understand a variety of business and economic situations. So I'm just going to put here, help us understand. Numerical facts that help us understand our world, right? Business, economic situations, and otherwise. Like, what percentage of people die when they drive on this road? Right? And if it was like 87% of people, you know what? Like Mount Everest, it's like 1 in 4, 25% of people who try to climb Mount Everest dies. It's like, okay, I have no need to try to climb Mount Everest. Like 25% of the people who go up it die. Enjoy. It's not something that calls me. So it helps us, numerical facts that help us understand our world. Statistics can also refer to the art and science of collecting, analyzing, presenting, and interpreting data, which is, again, helping us understand our world. We collect data, we analyze it, we present it, we interpret it. And having numerical understandings of things is super important. Like if you understand how things work on, most of the time, a probabilistic kind of fashion, if you understand what's going on in the world, what is the probability of success, right? If you go into this career versus this career, what is the probability that you will make over $200,000 if you become a poet? What is the probability that you'll make over $200,000 if you become a doctor, right? Like understanding that can help you make better choices for your career. If you're going to work, you might as well get paid a good wage and earn some good money. And you can choose between being a poet or being a doctor. And statistically speaking, you have a higher probability of earning a larger salary if you become a doctor. Like just ballparking it without knowing the specific statistics, that's really good to know. Earlier today, I was talking with some students on campus about drug overdose deaths and fentanyl. And so I asked it. I have a friend who's the head of the Santa Cruz County Department of Health. And she said a lot of the street marijuana is being laced with fentanyl. And so I asked it, is marijuana purchased on the streets laced with fentanyl sometimes in California and specifically in Fresno? And this was the result that ChatGPT bumped out. And but just knowing that also up here, 70% of the 107,000 drug overdose deaths in America in 2023 were caused by fentanyl. Like fentanyl is a really big problem. And the takeaway from that is that you don't want to do any kind of substances that were purchased on the streets. Have a glass of wine, drink a beer, right? I'm going to advise you to wait until you're of legal age until you do that. Or if it's going to be a cannabis product, right? There's like cannabis store Fresno. There's cannabis stores in Fresno. And so here's one out at Palmanese that I saw one time when I was walking by. Went to a hummus restaurant out there. And so you could go to these places where you could buy cannabis products which are manufactured by companies and are going to have quality control applied to them. And so the probability that they will be laced with fentanyl is zero, very low to zero, right? Like knowing those statistics is really helpful. It could keep you alive. And if you buy it on the street, right, 70% of these 107,543 drug overdose deaths were caused by fentanyl. So if you're buying it on the street, you're risking your life. So that's really important to know, really important to know. And just as an anecdote, why that we're talking about this, why this came up, you could go to Health Services, Fresno City College Health Services, and they have a nurse on campus where you could see for all kinds of health issues. You'd like going to a doctor and they could do COVID testing. They could help you figure out what's going on with your health if you have something going on. They could help you with family planning. They could also help you with addiction if you have addiction issues, alcoholism or something else, other substances, or any other addiction. You could go there and they could give you guidance on that. And they also will give you fentanyl test strips if you know people who are purchasing substances on the street. They will give you fentanyl test strips, and they'll also give you Narcan. And Narcan is very good to carry, and you can learn about it, but it could save somebody's life. If you're somewhere and somebody overdoses on fentanyl, you could give them Narcan through the nose, and that buys them 20 or 30 more minutes of life, so you could get them to the hospital where they could be saved. And so that's super important because this is a big public health issue. And knowing that it's a big public health issue can help you make good decisions and take good actions. So again, statistics help us understand our world and make better decisions and take better actions. So when we start talking about numerical data, numerical facts, we're talking about data. And so data are the facts and figures that are collected, analyzed, summarized, and presented for interpretation. So data is just facts and figures and numbers. And all data are collected in a particular study are referred to as the data set, right, for that study. So when we do a study, that's referred to as a data set. And we have a data set. When we do studies, we usually study like a sample from an entire population. So the population of this study here, where there's 107,000 drug overdose deaths, the population is all of the United States, right? And then for this study, the entire population, right? We have all the data from all of the population. It wasn't done with a sample. But with other studies, we'll take a sample from the population. We'll sample 50 students from Fresno City College and ask them questions. And then based on the results of those 50 students, we will make inferences about the entire population. So the 50 student samples, right? The 50 students, will sample 50 students, and that sample will allow us to make inferences about the entire population. And so that is easier than sampling everybody, right? You could sample 50 people and you could get information, but trying to get information from everybody, all 26,000 students at Fresno City College, wow, that's going to take a lot of effort. So data sets, elements, variables, and observations. These are all vocabulary words. We've learned what data and data sets are. And so, but we have some other things. So elements. So here's an element. Armenia is an element with all of its related data. Australia is an element with its related data. Austria, Azerbaijan, Bahrain, however you say these, I don't know, right? But these are all elements in a sample or in a study. And then each element has a variable. So here's the WTO status variable, and you can see what it is for each one of these. Here's per capita GDP variable, and you can see what it is for each one of these countries, each one of these elements. Here's something called a Fitch rating, right, for each one of these elements, each one of these countries, and you can see what it is for each one of those. This is an observation. So here's an observation for Australia, right? Here's the observation for Austria. It's the element and the data for each variable that you collected about for each element. So an observation is one element, and then it has variables, and the observation includes the data that you collected for the variables for that element. So it's kind of just like, again, when you get into some new domain, you have to learn the new language, and that's kind of what you're learning here. And then all of this data is called our data set for our study, right? This is all called our data set. So those are the terminologies there. So elements are the entities on which data are collected. So I'm just going to copy this, Control C, and come over here, Control V, and paste it. And then I'm going to make this smaller. Whoop, 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 whoop. And then I'm going to just put this over here so we still have a little bit of a reference to it. And yeah, I think that's fine. It'd be nice if this was a little bit bigger. So let me see if I could bring this over here and bring this up like this. And that looks pretty good. And then I can make this a little bit bigger, bring this over and make that a little bit bigger like that. That's pretty much it. All right, so an element are the entities on which data is collected. So our elements here are Armenia, Australia, Austria, those are our elements. A variable is a characteristic of interest for the elements. So that's like a really weird phrase. And I sometimes think that statistics has an inferiority complex where it has to kind of be like, hey, I'm important, this is complicated. You know, characteristic of interest is one of those phrases which is unnecessarily complex, and I think that is off-putting for a lot of people because it just becomes a little bit confusing and overwhelming. But all we're saying is that for each element that we're going to study, it's an entity on which data is collected, and the data that's being collected is we have different variables. We have WTO status, we have per capita GDP, and so I think I could go to, where's my slideshow? Present. I always have a hard time. It's way up here, I think. Slideshow, there we go. This might make it bigger. That's a little bit better. So WTO status is a variable. You could be a member or you could be an observer. Per capita GDP is a numerical entry. Fitch rating is an entry, right? But these are all variables. WTO, per capita, Fitch rating. And these are all elements. A set of measurements obtained for a particular element is called an observation. So these are all observations. It's a set of elements. A set of measurements obtained for a particular element is an observation. So here's an observation of Australia, the element Australia. It's a member. It has this for the GDP. It has this for the Fitch rating, right? That is an observation. A data set within elements contains n observations, right? So here is 1, 2, 3, 4, 5 elements. And here's the observation for Armenia. Here's the observation for Australia. Here's the observation for Austria. Here's the observation for that country and for this country. So it has 5 elements and we have 5 observations. And the total number of data values in a complete data set is the number of elements multiplied by the number of variables. And so here are our elements, 5, and we have 3 variables. So 3 times 5 is 15, and that's the number of data values that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the total number of data values in a complete data set, this is our entire data set, is the number of elements, right? 1, 2, 3, 4, 5 elements, multiplied by the number of variables, 1, 2, 3 variables. Okay, just new terminology. We're just learning about how do we talk about data, and yeah, so we're learning that new terminology. And then now we get into scales of measurement, and so this is going to be the next 10 slides, and I'm just going to pause the video here and take a little break for myself. You might want to do the same, get a glass of water, get up and stretch, do some push-ups, do some jumping jacks, whatever it is, but just take a break and get a drink of water, get up, walk around, come back, and resume the video, and that will let your mind, let the material you just learned about elements and variables and observations and data sets, it'll let that information sink into your brain, and after you've taken that little break, come on back and resume the video as I'm going to do in just a second, and that will help you learn. All right, welcome back. Now we're going to talk about scales of measurement. And so a scale of measurement is just a different way to sort of categorize the different data that we might capture. So here we're capturing some data where it's member or observer. Here we're capturing some data which is numerical and it's some sort of GDP. This is money. Here we're capturing some data which is some kind of rating with A's and B's, right? And so here, scales of measurement, we're talking about how do we think about the different ways that we could capture data? Is it going to be a word? Is it going to be some kind of a rating like this, some scale? Is it going to be some numerical value? And the way we think about the different ways that we can measure things with data is that there's 4 categories. And so these 4 categories, these scales of measurement, include nominal, ordinal, interval, and ratio. And I think about those again with, this acronym NOIR. And if you go here and you say film noir, you're going to see black and white kind of images of like crime thrillers and things like that. Is like a period in film, and it became film noir. It's usually like some detective, like, well, this would be a good ChatGPT question. Give me a short explanation of film noir. And I usually include please and things like that. Cinematic style and genre that emerged in the 40s and 50s, characterized by dark, moody atmosphere and themes of crime, moral ambiguity, and existential dread. And they have femme fatales and hard-boiled detectives and complex, cynical storylines. And visually, film noir is known for its use of high contrast lighting, deep shadows, unusual camera angles, creating a sense of tension and unease. The term noir, French for black or dark, reflects the genre's exploration of the darker aspects of human nature and society. Wasn't there a novel that is in this genre, a series of novels that were in this genre that had a protagonist called Mike Hammer or something like that? What was the protagonist's name and who wrote those books? Right? You could just ask it, like, talk to it like you're talking to a really smart friend. And I'm showing you this so you're starting to get a sense of how you could use ChatGPT. And you can see here, maybe I've stumped it. I'm going to pause the video and see if it comes up with an answer. So it's not coming up with an answer, and sometimes that happens. It just hangs for whatever reason. Maybe there's a network issue, and there's a ton of people who are using ChatGPT, so that can happen. So I'm just going to click stop right here, and I'm going to hit the thumbs down on that. And, there's, didn't fully follow instructions is the closest. And now I'm just going to put that in again and then just submit it once more and see what happens this time. And now here we go. So this time it got the answer. And that's really good for you to see too, right? Nothing's perfect. Perfection is an illusion. Everything sometimes has errors, and you just have to keep being persistent and trying things. So the protagonist you're thinking of is Mike Hammer, hard-boiled private detective, and is written by Mickey Spillane. And so those are famous books, which I wasn't remembering in the noir genre. So here we have, I remember scales of measurement with this acronym NOIR, nominal, ordinal, interval, ratio, where each of these letters is the first letter of each of those words. And that's called a mnemonic device. And so a mnemonic device, and I'm sharing this with you so you can learn how to learn. And I'm going to define that and hit enter. And yeah, I mean that one. And a mnemonic device, it's not really giving me a good definition, but here's their AI version, is a learning technique that helps people remember information by associating it with something easier to remember. And that's what a mnemonic device is. If I wanted to, I could go to ChatGPT and see what it gives me, and I could ask ChatGPT for examples. And I like the AI at ChatGPT better than the AI that Google sometimes pops up here when you get search results. So that's the mnemonic device I use to remember these scales of measurement, nominal, ordinal, interval, ratio. And the scale determines the amount of information contained in the data, right? So it really kind of tells you about the data and how much, what kind of information can be stored with the data. So if you look at like here, member observer, that's like one type of information that's being conveyed by the data. But here, these numerical values is different information being conveyed by the data. So again, this inferiority complex of statistics, I think, makes statements like these come out, which are overly complex. Scale determines the amount of information contained in the data. Like if you didn't have somebody explain it to you, you'd be kind of like, I don't know what that means. The scale indicates the data summarization and statistical analyses that are most appropriate and available. Like you could do different data analysis, right? You could do different things with numbers than you could do with member or observer or with this A-B stuff. And so the scale determines what kind of analysis you could do. And so a nominal scale, right? We're talking about nominal, ordinal, interval, ratio. Nominal are data are labels or names used to identify an attribute of the element. A non-numeric label or numeric code may be used. So this is nominal right here, member, observer, right? Like it's just, that's nominal data. You could be a member, you could be an observer, that's it, right? So that's what nominal is. It's just data or labels. And so here are some more examples. The WTO status category for the nations in the previous example, this one right here, right, is classified using non-numerical labels, member or observer. Alternatively, a numeric code could be used for the WTO status variable by letting 1 denote member nation and 2 denote observer nation. So instead of like entering member or observer, we could enter 1 or 2 there in our table, and 1 would mean member and 2 would mean observer is what that's saying there. So yeah, the data stored in the WTO status variable is nominal data. It's nominal data. Then we have ordinal. So we're learning nominal, ordinal, and then the I, nominal, ordinal, interval, and ratio. And ordinals, the data have the properties of nominal data and the order or rank of the data is meaningful. So just based upon that, right, when we look at this data here, so I'm just going to make this a little bit bigger and bring that down like that. When we look at this data here, this is nominal, the WTO status, but over here the Fitch rating would be ordinal, right? Because the properties of nominal data and the order or rank of the data is meaningful. Like triple A is better than triple B, and triple B is better than triple negative B, and triple negative B is maybe better than double negative B, right? And so you could actually start to order these. You could rank them. The order or the rank of the data is meaningful. Whereas here, ordering and ranking this doesn't really convey any difference, any meaning. I don't know if observer is a better status than member, right? I don't know that. So ordering them or ranking them here with nominal data doesn't make a difference. But with ordinal data, we could provide some sense of rank or hierarchy or order to the data. So ordinal data is like nominal, but now you could rank it. It has some sort of valence to it, some sort of a positive or negative attribute to it. And again, what we're doing is we're just learning vocabulary here, and we're learning to think about data and how do we talk about data and what are different categories of data. Well, there's nominal data, there's ordinal data, right? This is nominal here, here's ordinal, and now we're going to learn. And so here's another example of ordinal, and after this we'll learn about interval. So here's an example of ordinal. The non-numeric rating labels AA to F for Fitch rating. These can be ranked, ordered from best credit rating to poorest credit rating. Numerical code can also be used. Class rank of a student in school, right, would be another example of ordinal. So here now we have interval. And I think about nominal and ordinal as their own category, and interval and ratio as another category, because nominal and ordinal is kind of dealing with words, and interval and ratio starts to deal with numbers. So interval data, the data have the properties of ordinal data, and the interval between the observations is expressed in terms of a fixed unit of measure. Interval data are always numeric. And so here's an example about SAT scores. But when I look at this, so the difference between interval and ratio is that ratio is going to have a 0, at which point you can't go further less than 0. So an example of a ratio data where there is a 0 and like that's just kind of like the stopping point might be, you know, how tall is somebody? Like you can't be negative height, right? You could start at like some height, theoretically, or how tall is some living being. It could be an ant, and it could be like 1 centimeter. But you can't have a negative height, right? And so that would be like a ratio. And you could say that, you know, if I'm 6 foot and somebody is 5 feet, right? You could say that I am like 1/6 higher, you know, that person is 5'6", my height, right? And so the ratio matters with ratio data, and there's like a 0 point. With interval, there is no 0 point, and the interval between the data has meaning. And so I'd say GDP here is interval data. And I'm saying I would say, because I'm no expert with statistics, I know some stuff. I took statistics twice as an undergraduate and also in graduate school. And 24 years later, they asked me to teach statistics again, well, for the first time. So that's the third time I've been through statistics, which was last spring. And now I'm recording this lecture in the fall. This is the fourth time, so I'm no expert. So if you know stuff that I don't know, please send me a note or an email and help me learn. But I know enough. And so sometimes I'll be exploring this with you and formulating my expression of my understanding of it. So if you have some insights into it, which I do not have, I'd love to hear your insights. But I would say that GDP here is an interval because it has a 0, but you know, maybe it could be negative. Like if a country didn't produce anything and they just consumed, maybe GDP would be negative, right? They consumed more than they made. And so maybe GDP could be negative. And so that would make it a ratio because there's no set 0 point. But the interval here, you know, with it being possible to be negative, the interval here matters, right? The interval between 3,615 and 3,879, like we could see the difference between those two. That interval tells us something. Like this country is this much more than that country in GDP. So that's interval. Another example of interval is SAT score of 1985, SAT score of 1880. And I'm just looking to see what time it is because my kids just got home. And, you know, you can see Melissa scored 105 points more than Kevin. I'm going to go say hi to my kids, and I'll be back in just a second. All right, I am back, and I got a drink, and my kids got home, and we got some new kittens, and they're excited about it. The other day, we got the kittens just yesterday, and I'm just checking to make sure that this little clock is going up, that I'm actually recording. Excuse me. All right, so that's nominal, ordinal, interval, and now we have ratio. And with ratio, the data have all the properties of interval data, and the ratio of two values is meaningful. So variables such as distance, height, weight, and time use the ratio scale. And time, right? So time all use the ratio scale. This scale must contain a 0 value that indicates that nothing exists for the variable at the 0 point. So like height, right? Like it's got a 0 value, and then there's nothing that has a height of 0. So I'm just going to make this a little bit bigger so we could see this here. But those are all ratio. You got to have that 0 point, and the ratio makes a difference. So here's an example. College records show 36 credit hours earned. So you could have 0 credit hours. You can't have negative credit hours earned, but you start from 0 and you earn up. Well, Kevin's record shows 72 credit hours. Kevin has twice as many credit hours earned as Melissa does, right? So that ratio can be determined. Data can further be classified. So now we're leaving nominal, ordinal, interval, and ratio. And we're just learning words that we use to talk about data. And now we're going to talk about categorical and quantitative data. So I like categorical. It can be thought of as categorical or qualitative. So qualitative, right? And I have like 90% certainty on that. So I'm just going to Control A, Control C, and then come over here. And so I'm going back to statistics conversation right here. I clicked back to the statistics conversation, and I'm going to just paste this in. I'm going to say, can categorical data also be known and talked about, known and talked about as qualitative data. All right, I'm going to put that in. And yes, categorical data is often referred to as qualitative data. Both terms describe data that can be sorted into categories rather than measured numerically. And categorical data, qualitative data, represents characteristics or attributes. Data is grouped into categories or labels, colors, types, names. Examples include gender, you're male or you're female, types of cuisine, Italian or Mexican, or brand of a product, Apple or Samsung. And types of categorical data include nominal data and ordinal data, right? Categories with no specific order and categories with a meaningful order but without consistent intervals. So when you see the terms categorical data or qualitative data, they're essentially referring to the same concept, data that describes qualities or characteristics, qualitative, quality, right? And is divided into categories, categorical data or qualitative data, rather than being measured numerically. Please also explain. So we have qualitative, quantitative data. And so I'm showing you here how you could use ChatGPT to help you learn. So as you're reading through things in your textbook and you're coming across concepts in any class, it's really cool just to kind of ask questions of ChatGPT and have this exploration of how does it talk about stuff and what kind of examples does it give you. And so here it says quantitative data refers to data that can be measured or quantified. It can be expressed numerically. This type of data represents quantities. It can be quantified. It's quantitative. And it allows for mathematical operations such as addition, subtraction, multiplication, division. Quantitative data is often, because you could do that with numbers, right? You could do addition, subtraction, multiplication, division. Quantitative data is often used to measure how much, how many, or how often something occurs. So key points of quantitative data represents numerical values or quantities, can be counted or measured, allows for mathematical operations, making it suitable for a wide range of statistical analyses. And types of quantitative data, we have discrete data and we have continuous data, right? So discrete is going to be like number of students in a class. You're not going to have 20.2 students in a class. It's discrete, right? Or the number of cars in a parking lot, or the number of books on a shelf. And continuous data is going to be like the height of individuals, right? You could be, it's like a continuous spectrum. You could be anywhere from 0 to however high. Or the weight of objects, continuum. It's a continuum from 0 up to some weight, right? With all the little fractions and decimal points between. Or the time completed the time taken to complete a task. Right? Like it's going to be continuous from 0 up to some fractional point. And so we have discrete and continuous quantitative data. And quantitative data and scales of measurement. Quantitative data can be associated with both interval scale and ratio scale. And so you can pause the video and you can read through those again. Analysis of quantitative data. Quantitative data is well suited for a variety of statistical analyses, including calculating means, medians, modes, right? We could, with numbers, we could do addition, subtraction, multiplication, and division, and performing operations like addition, subtraction, multiplication, division, analyzing distribution, variances, standard deviations, and correlations. And because quantitative data is numerical, allows for precise measurement and detailed analysis, making it a powerful tool in the fields of science, economics, engineering, statistics, and many others, right? So really kind of we're thinking about the different types of data, the different ways we can measure things and categorize things. Nominal, ordinal, interval, ratio, qualitative, quantitative. Qualitative is nominal and ordinal, quantitative is interval and ratio. And when we deal with quantitative data, it can be discrete and it can also be continuous. So discrete is 1, 2, 3, 4. Continuous is 1.78366492. Right? That's continuous. It's some fraction, right? So that's how we can start to categorize data and think about data and words we use to talk about data. And we're just kind of gaining a foundation for this field of statistics and how do we start thinking about and talking about data. It's just like, you know, people often say that Eskimos have like, you know, 100 words for snow or whatever. And, you know, if you're not deeply involved in understanding something, you might have one word, it's snow, you know, but if you're deeply involved in it, you've got all these different ways of describing the type of snow, Well, if you haven't gotten into statistics, it's just statistics, it's numbers. And if you do get into statistics, you're like, well, is it qualitative or is it quantitative? Is it nominal or ordinal if it's qualitative? Is it interval or is it ratio if it's quantitative? And if it's quantitative, is it discrete or is it continuous? Right? We're learning all these words so that we could really start to kind of talk about and understand data and what kind of data are we capturing. And with quantitative data, we could do a lot of math, right? Kind of hard to do math on stuff like member observer or BBAA. Can't really figure things out like averages or median, mode, right? Can't figure that out with nominal, ordinal, qualitative data. But with quantitative interval ratio data, you can start to figure out mean, median, mode, that kind of stuff. And variance, right? We could start to figure that stuff out. We could do math on it. And so we could do quantitative, quantify, we could do quantitative analysis with that kind of, with quantitative data that is continuous or discrete. And we could start to do different kinds of statistics with that data. So that's what we're getting understanding of here. All right, so we went through categorical, qualitative, and quantitative data. And data can be further classified as categorical or quantitative. And the statistical analysis that is appropriate depends on whether the data for the variable is categorical or quantitative. So, right, if it's categorical, qualitative, I like qualitative better than categorical, right? But I'm just going to put it in there, qualitative. So it depends upon whether it's qualitative or quantitative, the type of analysis, statistical analysis we could do on the data. And in general, there are more alternatives for statistical analysis when the data are quantitative, right? There's more you could do when the data is quantitative. So here we're looking at categorical, or again, I'm going to put here qualitative. That's the way I learned about it, and so that's the way I think about it. I like also the way qualitative, quantitative, kind of the assonance. I think that's the word, the assonance of that. So what does assonance mean? And did I spell that correctly? Right? Like, you know, just showing you kind of like how you could just have conversations. And assonance, two S's, not assonance, is a literary device in which the repetition of vowel sounds occurs in nearby words, typically within a line of poetry or prose. It is often used to create a particular mood or to emphasize certain sounds in the text. An example of assonance would be the repetition of the O sound in the phrase, the low moan of the old oak, right? So qualitative, quantitative, I like the assonance of that as opposed to categorical and quantitative. Doesn't flow as well. Anyhow, qualitative data, labels or names used to identify an attribute of each element. So labels or names used to identify an attribute of each element. So let's get this little thing right here again and come back here and put that in, and we'll just make it a little bit smaller so that we could see this all on the screen. We'll put it down in the corner, and then we'll make this one a little bit more up. And then we'll bring this one up here like this so we could see it. There we go. All right, so labels or names, qualitative data used to identify an attribute of each element, member, observer, BAA, often referred to as qualitative data, use either a nominal or ordinal scale measurement. These are things we read about already. It can be either numeric or non-numeric. And so numeric, these are non-numeric, this is non-numeric, but we could have had 0 or 1 represent member, observer. That's what it means by numeric, non-numeric. You really wouldn't do math on that. You could find out what percentage were members, what percentage were observers, right? But, you know, statistical analysis is rather limited. You can't find out variance, for instance. We'll learn about variance. Quantitative data indicates how many or how much. It's discrete or it's continuous. We learned about that. And quantitative data is always numeric. And ordinary arithmetic operations are meaningful for quantitative data. So quantitative data, it's quantified stuff. It's always numeric. And with quantitative data, you could do arithmetic operations. And cross-sectional data. So cross-sectional data is at a certain point in time. So it's at the same point in time, right? So we're saying, hey, at this point in time, let me bring this one over here. And let's see, quantitative, cross-sectional, there we go. So at this point in time, right, this is the GDP of these countries at this one point in time. So that's cross-sectional data. So you can see that per GDP or the Fitch rating. And then here we have time series data. And time series data is data collected over a period of time. Like here's the price of gasoline from 2012 to 2018. Shows us what happened in the past, identifies trends over time, helps us project future values for the time series. And so here is time series data, price per gallon for conventional regular gas from, I don't know what year this is, but whatever. January, I guess, oh, this is from 2012 to 2018. So the price of gas was here, it's kind of gone down. But you could look at, like, you know, if we look at Bitcoin price, USD, oh wow, Bitcoin's really gone kind of back up. It was down to 55,000. So you can see the Bitcoin price over time. And down here earlier is like, when was that? February 21st of, this is 2024, because that's just 6 months. It was at like what, where was that? 50,000. Now it's up to 60,000. Or you could do a year, and a year ago it was at 26,000 in August of 2023. That's amazing. You know, or you could do the max, and you could kind of see it had this big drop right here. 2022 is down to like 16,000 a coin. That would have been a good time to buy it. And so you know, this is time series data. It shows us data over time series. That's the point. All right. I'm just going to make sure I'm recording, and I see those numbers going up, thankfully. Then we have, how do we get our data? Where do we get our data? So you can just pause the video and you could read through this, but there's all kinds of sources of data that are already out there. So these are existing sources. And instead of going and trying to do studies to get your own data, you could find data that already exists. And so here, if you're in a company, these are places where you might be able to get data from internal records, internal company records. And here's data from different government agencies, data.gov, right? And all these different agencies, you could get data from there and do analysis on them. And then you could also do studies. And there's two types of studies you could do. You could do an observational study. You could also do an experiment. So in observational studies, you're just going to observe what is already occurring, and not do any kind of a formal study or set any types of controls really on it. And you just might observe how many students go through this door wearing red on, you know, Mondays from 8 to 9 a.m. And so that's an observational study. No attempt is made to control or influence the variables of interest. So the variable of interest in that case would be how many students are wearing red, right? Red clothes. So a survey might also be a good example. You could just ask people questions. So an example of an observational study is researchers observing a randomly selected group of customers that enter Walmart to collect data on variables such as time spent in store, gender of the customer, and the amount spent. So that's an observational study. That's one way to get data. An experimental study is the variable of interest is first identified, and then one or more variables are identified and controlled so that data can be obtained about how they influence the variable of interest. So the largest experimental study ever conducted is believed to be a 1954 Public Health Service experiment. For the polio vaccine, nearly 2 million children were selected. So you actually create an experiment, and you know, you have the variable of interest, and then you look at how different variables influence your variable of interest. So data, and you know what, let's clarify that. Experimental versus observation. So again, we're on our statistical conversation here, so I'm clicking back on this chat. And please explain the difference to me of gathering data through, and let's just see what the textbook called it. And the textbook called it observational studies, an observational study versus an experimental study. And is that what the textbook called it? So we'll come back down here, and yeah, experimental studies is the word the textbook used. Please also give me 2 simple examples to illustrate each. And again, I'm showing you this so that you can kind of learn how you could use ChatGPT to help you learn. because I heard it said one time, it's better to teach somebody to fish than to give them a fish. And if I teach you how to fish, if I teach you how to learn, then you are empowered to learn for the rest of your life, which is amazing. And nothing can hold you back. And you could go start using these tools to learn whatever you want to learn and to really grow your knowledge more quickly. Versus if I'm just like, memorize these terms, right? Like, I don't know what good that did you. Not a lot. I just kind of gave you a fish. Feed you for a day instead of for your life. The difference between gathering data through an observational study and an experimental study lies in the way the data is collected and the level of control the researcher has over the variables being studied. Like, I just like this definition so much more than the textbook. Observational study, definition. In an observational study, the researcher observes and records data without manipulating any variables. The researcher does not intervene but simply collects data on what naturally occurs in the real world. The goal is to gather information about associations or correlations between variables without establishing cause and effect relationships. Characteristics, no manipulation, natural setting, correlation. The study can identify correlations but not causation. Data is collected, so correlation would be like people who come into the grocery store when they buy beer, they also buy chips, right? But you can't say causation. Causation is more like if I throw a rock at a window, the window breaks. It caused the window to break, right? So that's causation. Example 1, a researcher wants to study the relationship between smoking and lung cancer. They observe a group of people over time, recording how many of them smoke and how many of them develop lung cancer. The researcher does not ask anyone to start or stop smoking. They simply observe what happens. A sociologist studies the eating habits of teenagers in a particular city by observing what they eat at school lunches over a semester. The researcher does not influence the food choices or the availability of certain foods. They only record what the teenagers choose to eat. That's an observational study. Experimental study. In an experimental study, the researcher actively manipulates one or more variables, independent variables, to observe the effect on another variable, the dependent variable. This type of study is designed to establish cause and effect relationships. Characteristics, manipulation. The researcher changes or controls one or more variables. Controlled environment. Experiments are often conducted in controlled environments where extraneous variables can be minimized. Causation. The study aims to determine the causal relationships between variables. Example 1. A researcher wants to test the effect of a new drug on blood pressure. They randomly assign participants to two groups. One group receives the new drug, treatment group. Another group receives a placebo, control group. The researcher then measures the blood pressure of participants in both groups to see if the drug has a significant effect. Example 2. A psychologist wants to determine if a specific teaching method improves students' test scores. They randomly assign students to two groups. One group is taught using the traditional method, and the other group is taught using the new method. After a few weeks, the researcher compares the test scores of the two groups to see if the new teaching method leads to higher scores. Key differences. Control. In an experimental study, the researcher has control over the independent variables and can manipulate them to observe the effects. In an observational study, the researcher does not intervene and simply records what naturally occurs. They observe what's occurring. Causality. Experimental studies can establish cause and effect relationships, right? Like the new teaching method caused greater test scores, while observational studies can only identify associations or correlations. Environment. Experimental studies are often conducted in controlled environments, whereas observational studies take place in natural settings. These differences are crucial when deciding how to design a study, as they determine the type of conclusions that can be drawn from the research. So that will take a minute to wrap your head around, but that gives you a little bit of an introduction. And if you want to read through that again, you could pause the video right here, right? And then you could also pause the video right here. And then you could also pause the video again right there, and you could read through those again. So that's an observational study versus experimental study. And then there are some considerations for acquiring data. How long is it going to take you to acquire the data? How much will it cost? What kind of errors might be introduced in the acquisition process? You could pause the video and read through that. And then there is descriptive statistics. So again, now we're shifting gears and moving into a new phrase, And so this is just more terminology that we're learning about in relation to statistics. It might be a good time for another break. So why don't you pause the video and do a few more push-ups, or go get another beverage and then come back and unpause the video and continue. So descriptive statistics are statistics that describe what's going on in the world. Most of the statistical information in newspapers, magazines, company reports, and other publications consist of data that are summarized and presented in a form that is easy to understand. Such summaries of data, which may be tabular, graphical, or numerical, are referred to as descriptive statistics. So you could have like really arcane statistical data, and then you could make that more descriptive by creating some table or some graph or some numerical representation and make it more descriptive and palatable for people. So here's an example. The manager of Hudson Auto would like to have a better understanding of the cost of parts used in the engine tune-ups performed in her shop. She examines 50 customer invoices for tune-ups. The cost of parts, rounded to the nearest dollar, are listed in the next slide. So here's the cost of parts for 50 tune-ups. And then here's a table summary of the frequency and percent frequency. So the cost in the 50 to 59 category, we had 2 instances of that. $60 to $69, 13 instances of that for parts. 16 instances of $70 to $79, 7 of this area, 7 of that area, and 5 of that area. And then the percent frequency of that. So 2 out of 50 is 4%. 13 out of 50 is 26%, right? Because that 13 out of 50 would be the same as 26 out of 100. So that's the percent frequency. And this is descriptive statistics. It's giving us description of what the cost of parts is based upon our sample of 50 customers coming into the auto shop for a tune-up. And so here's a graphical summary. This is descriptive statistics, right? But we took these categories and then we just graphed them out. 2 people, like 13 people, 16 people, right? But this gives us a visual representation, descriptive statistics, a visual representation of the cost of parts for people who come in for a tune-up when we did a sample of 50 of our customers, right? And so the entire population would be all of our customers. Our sample is just 50 of our customers. And then we make inferences from that sample about the entire population. So here's a numerical descriptive statistics. The most common numerical descriptive statistic is the mean or the average. The mean demonstrates a measure of the central tendency or central location of the data for a variable. So central tendency or central location, like mean, right? If we have some data, and so here, I'm just going to go in here and create a new spreadsheet. So actually I have spreadsheets in here, and I'm going to create this spreadsheet. I'm going to call it, create and share. I'm going to call it chapter 1. We'll put that up here. We'll call it 01, right? And so I'm just going to demonstrate some stuff. I'm going to zoom in on this. I'm going to make this a little bit bigger because my eyes aren't what they used to be. I'm going to close this over here. So I did this here, 200% to make that bigger. And then we have some data back here, right? So here's some data. So I'm going to grab this data. I'm going to copy that, Control C, and I'm going to come back over here and I'm going to paste it. Control Shift V. I could go to Edit, and I could go to Paste Special, and I could say Values Only. And so pasted all that data there. So there are my 50. And I could do my average, right? So I could insert here, and I could go to a function. That's not where the function is. Format data. So where did I leave my glasses? They're on my shirt. So I'm just looking for functions here, and data. We've got named functions there. I'm going to go to functions over here and see what I've got. So I have learn more here, but I just want average right here. So now it's saying, what do you want an average of? I want an average of all of that. And my average is 78.98. So in the middle, the average of all this data, right, to measure of central tendency or central location is 78.98. That's kind of like, somewhat sort of like the average. It's like of all the data, right, this is sort of, there's this amount on this side, half is on this side, half is on that side in terms of values, and that's the average. And I think average is interesting to explore. So another way I could have calculated that average is I could have summed all this up. So I'm going to sum up all that data. So I'm going to choose sum and sum all that up. And so here's my sum, and I'm going to press enter. That's my sum. But then if I come up here to that formula, and I know there's 50 elements there, I'm going to divide by 50. And so when I sum up all the data and then divide by the number of elements in the data, it's going to give me the same answer. And we could look at, like, you know, measures of central tendency. So here if we had, like, you know, 8, here if we had, like, we'll just do a few numbers. Like if we had like 8, and then we had like 12, and we had 10, and we had 8, and we had 12, right? The average on that is going to be 10. So I'm going to go up here, and I'm going to go to average, and I'm going to go like this, and the average on that is 10, right? That's my average. And if I had another set of data, so I'm just going to create a little separator here by doing that, and then I'm going to have another set of data here, and I could have 0, and I could have 20, and I could have 0, and I could have you know, 0 once more, and then I could have 40. And the average on this, if I have 60 and I divide that by 5, that's going to be 12. I need to get this down to 50, so I'm going to make that one 30. So now I'm going to do this again and get my average, and my average is going to be exactly the same, right? And so the measure of central tendency, the central sort of location, where from this point here, like this is the average, that's what the average is. The average is 10 for each of those, but you could see that the data is really different. So if I'm looking, like if this is my income over 5 days in, like, you know, hundreds of dollars or something, that'd be pretty good income, right? And it's pretty stable. Some days I make 8, or let's say I'm like doing sales. Some days I close 8 deals, some days I close 12 deals, some days I close 10. But every day I'm doing pretty good. There's not a lot of variance in that data. But in this data, right, there's days where I just don't close any. 3 days where I just strike out. But some days I'm big. I do like 20 or I do like 30. But at the end of the day, each of these people are closing on average the same amount of deals per day. You know, over 5 days, this person closed 50 right here. And over 5 days, this person closed 50. And if we add this up right there, I'm just going to do an equal to sum. And then sum up, I want to sum up through a 5. So that's going through A6 right now. I want to change that to A5. So it's just this data here that's highlighted. If I sum that up, that's 50. And same thing if I sum up the one right above it there, that is also 50. If I double click this, I can see that's what's being summed up, right? They're both closing the same amount of deals. This person has way more variance than this. But on average, each day, they're closing 10 deals. Over 5 days, they each got 50. So on average, they're doing 10 a day, right? So the average is the central location or the central tendency. And so that's you know, here you see the most common numerical descriptive statistic is the mean or the average. And then you're also gaining some insight there into this idea of variance. So if we want to understand data, right, we have to sort of understand, like, okay, look, each salesperson's doing 50 deals over 5 days, which means on average each day they're doing 10. But this salesperson has way less variance, right? They're more stable, they're more predictable, right? They're like between 8 to 12 sales a day, right, that they're closing. This person has a lot of variance, way less predictable. Some days they strike out, some days they hit huge, right? So this person's like, well, how do we get this person to do, you know, something more consistently high on every day? Why are they having off days here? But understanding data gives us insights into the world where we could start to figure out, like if this was a real business situation, let's study this person and see how do they do so well on these certain days, and why on these days do they strike out so badly, and how do we, you know, increase so that they're doing high sales on every day. So maybe this person is a little bit manic. On some days they're just really up and excited. Some days they're really down, and how do we stabilize that so that they're always doing a great job. So anyhow, that's a numerical descriptive statistic, the mean or the average, and you start to get some insight into, like, how talking about data, what's the average number of sales they do each day, What is the variance, right? How much does it vary around the average, the mean? How much does it vary around the mean? And that variance is also really good insight to let us see like who's more consistent, who's less consistent, and then having those descriptive statistics, having those insights, those descriptions of the world through statistics allows us to start to think about things and to formulate different ideas about how's the world working and to have insights into how the world's working so that we can make better decisions and take better actions. So that's the mean demonstrates a measure of central tendency or central location of the data for a variable. Hudson's mean cost of parts based on the 50 tune-up study is $79, found by summing up the 50 cost values and then dividing by 50. So that's what we did over here, right? We found the mean by summing up the amount of sales each day and dividing by the number of sales. 50 divided by 5 is 10. Summing up the sales they did for each day, which is 50, and then dividing by 5 days gives us the mean of 10. So the next thing is statistical inference. So there's a population, which is all of the, like in the auto shop example, it's all of the customers who come into the auto shop. And instead of surveying all the customers in the auto shop, the entire population, we just take a sample and we survey a sample, and then we make inferences about the entire population. So population is the set of all elements of interest in a particular study. The sample, right, so the population is all the customers or all the students. A sample is a subset of the population. And then statistical inference is the process of using data obtained from the sample to make estimates and test hypotheses about the characteristics of the population. And a census is collecting data for the entire population, and a sample survey is collecting data from a sample, for a sample. And so here's an example of process of statistical inference at the Hudson Auto example. The population consists of all tune-ups. The average cost of parts is unknown. A sample of 50 engine tune-ups is examined. The sample data provides a sample average parts cost of $79 per tune-up. The sample average is used to estimate the population average. We make an inference about the population based upon the sample.